Okay, y'all. Systems of linear equations. So we have lines. We solved ones that look like this, where we had whole numbers. Sometimes we had some negative whole numbers in there. So where do the two lines cross? And then we threw in like some fractions. Great. Where do the two lines cross? Okay. And then we did some with numbers like numbers that are what we call irrational. So like this. And oops, come here, boop, 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 come here, buddy. Okay, boop. Maybe like the square root of 2 and the square root of 3 and pi and e, whatever, okay? Now, what I want you to know is that that is no different than this. Now, you've been trained to know that that is the same as this many. It's a known fixed quantity. These are exactly the same way, all right? Problem is they can't be expressed using these symbols with a finite number of symbols. Like, that's great using the bar and, decimals. That's really also the bar with plus signs, right? But these, even though they're just like that, they have a fixed known quantity. You just have to accept their value, just like we accept that value. But if you try to portray this using zeros through nines and plus signs, it would take an infinite number of them. So the best we could do if we're going to use these symbols would be like dot, 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 because there's an infinite number of them with no pattern. So there's no finite number of these symbols we could use. There's other ways like this guy. You could say it's the ratio, of the circumference to the diameter of any circle. So these are numbers too. So you got what? 0, 1, all the way up through 9. And then with base 10, we could do numbers like 23 and so on. And with the bar, you can get numbers like this. Great. And those are our rationals. If you want to do decimals, you can do this. Dexter, I'm busy, buddy. All right, here, hop in my lap. Come on. Come on. All right, good boy. You're so helpful. Now you're in the way. Okay, so we did a problem like that last time, and it's tough because y'all are used to taking this and renaming it and turn it into that. And it turns out that numbers like this, you could just leave it like that. You could have just left this like this the whole time. So actually, it's less work. All right, so it's just, that's the name of the number. All right, leave it like that. That's just fine. So every one of these problems, we're just changing the numbers up here. And this is why we invented algebra, is because it's so much easier than arithmetic. Why don't we just solve all of them? All possible, where do two lines cross? So every one of these is, we have a number, I'll call it that. And then we have a number, I'll call it that. And then a number. And then down here we got different numbers. So I'll call this one A2. And I'll call this one B2. And I'll call this one C2. So just like 1 plus 2, that's a number. You could leave it like that, just like we left that like that. We could do the same here. We don't have to know ahead of time what values these are. Just let yourself know that that's a number. It's a fixed quantity. I like to think of it for my business students as a box of widgets. All right. This is a box where the lid is open and you can see how many are inside. This is a box where the lid is closed, but there's a number of widgets inside. It's fixed. We don't need to know how many are in there. It doesn't matter. We could still run our business. So let's run our business. Sweet. So if I want to do our standard old add them together, I'm trying to get rid of one of the variables. Okay, well, I need them to line up. So what I'm going to do is I'm going to say these two equations, these lines, they're exactly the same as these two lines. So what I'm going to do, I'm going to multiply everything up here by A2 and everything down here by a negative a1. So whatever these numbers are, if I multiply them, we write this like that. They're being multiplied. And then here, let's multiply them. I'm going to put the a's first. It doesn't matter. And then multiply everything. We don't need the dot. There. I just multiplied both sides of the equation by 2, or a2 in this case. Oops. So, let me clean this up a bit. And then the bottom one, why am I doing this? Because when we do this, I got negative a1, a2, and negative a1, b2, and negative a1, c2. Now I think I did it right. Everything got an a2. Boop, boop. Oh, I messed it up. It's good to double check. Don't wait till the very end to check your work. Check after each step. Everything got an a2, and now did everything get a negative a1? Negative a1, negative a? It did. All right, I think I'm confident. Same equations. It's just like if I took this and multiplied everything by 2. It's exactly the same equation, right? Okay. See, exact same thing. Might look funny, but you get used to it. Now, I did that because now these are samesies, right? And if I add them, I can make the x's go away. That, oh, look at that. I forgot my x. It's real tedious to write the x's over and over and the y's over and over. We're going to do something about it later. Since these are equal and opposite, when you add, they go away. So how many y's do I have? Well, imagine this is 3 and this is 2. You would have 3 minus 2 y's. Okay? So, just so you can see it, if I had this and I did this, I would have this many. That's how many y's. And I don't need to turn that into something else. I could just leave it like that. That's what we're going to do here. Okay? So how many y's do I have? I have this many. Boop, boop, boop. Minus this many. That's how many y's. And what is this equal to? That plus that. Again, this is just a number, and that's its name. Sure, it has a long name. It's not just a symbol, but actually, it is a symbol. That is a symbol all by itself. Okay, so if I had 2y equals 1, you would just do that, right? We can do the same thing, okay? So let's do that. So therefore, the y is this guy. Pow. Yeah. And divided by, oops, this number. That's our y value. Now, that's its name. It's no different than this. It just takes more pen strokes to write its name down, you know? All right, so that's it. That's y value. Now I'm going to put it in kind of like a purple here so I don't lose it. Now, maybe I could simplify it. No, we can't, because not until we know what the A's and B's and C's are. So, what is this? Well, y'all been taught to get the answer where the lines cross. Wherever these lines cross, they're just a couple of lines. Boop, boop. We now know that the y value is this. So, here is the line y equals that number. So now we just take that and plug it into either line to figure out what the x is. Cool, let's do it. If you've done enough of these, you're going to see that you're doing the same thing every time. So let's go to one of our equations. It doesn't matter which one. All right, this is the y value where these lines cross. So I'll just pick the first one. You could pick the second one. It doesn't matter. So let's see, then we substitute into original equations, all right? Either one. So let's see. here's our original equation, but now we know what y is. So I'm going to replace y with a known value. I say known, a fixed value. Well, we know the name of it, all right? So we know the name of the number y has to be this guy. So let's put that in there. Doodle-doodle-doo, boom, pow. There we go. That's the name of the y value. This is no different than 2x plus 3 equals 5. Number, number, number. The names are just bigger. That's fine. I'd rather write down a big name than do a whole bunch of calculations, right? Notice we don't have to calculate. We just leave the action buttons in there. So if I want to get this, what would I do? Well, if I had, again, this guy, I would subtract that, and then I would divide by that. That's what you do, right? Okay, well, let's just do that then. Who cares that the names are big? Okay, so this equation is exactly the same thing as if I just subtracted that number from both sides. So let's do that. Oh. Algebra was invented because arithmetic was hard. Algebra is so much easier. All right, now this is just a number. It has a really long name. It may as well be that. It's just the name of a number. Okay, I want to get this, so I'll divide both sides. Oh, let's go ahead and do it down here. So that equation is the same as this one, where I'll go ahead and put it up here. Well, divide by this, right? And see, that's the number 1, and you're just multiplying by 1, so we'll make that go away. Oops. Now, I could do this number, and then divide by this, right? I don't like that. We got all this going on. And I told y'all don't need division at all. There's no such thing. Don't even need to know anything about that. Right? If you have this guy, you don't have to divide by 2. You could just multiply by 1/2. Samesies, right? So now we don't need division at all. Just let's do that. It'll just look better. Okay. So instead of dividing by this, I'm just going to multiply by 1 over a1. It's the same thing. And that's where the x is. Now that is a long name. Maybe we can rewrite this name in different ways. If you wanted to, you could. But we're done. This is the x. This is plug in your a's and b's and c's, and you have the answer. So if you want to try to rewrite it, maybe we can. Maybe we could distribute that. If you wanted to, you could. B1 over A1, and then whatever this number is. It's just up to you. How do you like it? What do you think is prettiest or easiest to use? Okay. Up here, I'm only writing A1 once. Down here, I'm writing it twice, right? But up here, we have parentheses. If you wanted to, you could do this. Distribute the B1 up here and distribute the A1 down there if you wanted to. We would have A2, B1, C1, and then A1, B1, C2, and then A1, A2, B1, and then A1 times itself. We call that squared. Oh, I'm missing a 2 here. Boop. See? Okay. B2. You could write it like that if you wanted to. Oh, if you want to get rid of that, you could get a common denominator. Oh, how do you do that? Well, think about this. If we had 1/2 and 1/3, you could just multiply this by that and this by that. These are smart ones, right? And look, common denominator. That's all this is. It's a really long word symbol for a number. You could do that. It's a whole lot of work for nothing, but oops, if you wanted to make the name look different, you could totally do that. You could multiply this by a smart 1. This could be the number 3 for all we care, but right now that's its name if you wanted to. There's no need to do any of this, okay? There. So this is the same as this because this is just the number 1 we're multiplying by. Therefore, we still have equality. And then, let's see, we have to do, I'll have to make it smaller. Boy, this name's getting real big. Okay. And this guy is still equal to itself. But it doesn't have that. So we could do that. We could multiply it by A1 over A1. So now 2 times 3, 2 times 3. We have a common denominator. So you could have, let's see, A1 and whatever this number is, it doesn't matter. That's its name. If you wanted to. You don't have to do none of this at all. But then you could have, oops, add the tops across. So just like if we had 1/2 and 1/3, and you did this, and you did this, right? On the bottom, you got a 2 and a 3, and on the top, you got this times this, and this times it. Yeah, you could do all that. There's no need to do any of this, you know? But if it was just your prerogative to get rid of that symbol, you'd have to do all of this stuff. It sucks, right? You know, but we could. And so what do we have? We would have this guy, C1, and then all of this. This is what you're doing in arithmetic all the time when you simplify. Whole lot of work. Why? Because when they say simplify, they really mean get rid of the action buttons like minus and plus, and then remove any hidden times 1s or plus 0s. And now I'm going to put the A1 first, right? So we got a minus A1 times all of this, copy, paste, and then, okay. So I'm really doing arithmetic. There's no need to do any of this. But hey, if you want to have one fraction instead of 2 fractions, you got to do all of this. Common denominator. So if we want to get rid of the parentheses, we have to, distribute, boop. So we'd have A1, A2, B1, C1, minus A1 squared, B2, C1. And now I'll distribute the minus A1. We got minus A1, A2, B1, C1. A minus times a minus makes a plus. A1 squared, B1, C2, all over this. We'll distribute this guy. A1 squared, A2, B1, minus A1 cubed, B2. That's our x. Again, we didn't have to do any of that. This is totally legit right here. The very first thing we got. I mean, look at that. It took like 2 steps. We started here. We made samesies so that we could add and make the x's go away. That gave us our y. And then we shoved that up there into the y. And that gave us this. Move that over, divide by that, and boom. That was it. If you don't like that version of the name, you could do all of this work. You could get rid of this parenthesis if you wanted to. And then if you wanted to, you could get rid of this parenthesis if you wanted to. And if you didn't like 2 fractions, you could combine them. But that takes tons of work because the difference of the numbers on the bottom. But if you did all that, you could do this. Now, great. This is what they force you to do in arithmetic. All of this stuff, because this was just fine in the very first place. You don't have to add those. You don't have to. You just leave it like that. That's the answer. Boom. You know? Why do all this crazy work? There's no need to do that. Oh, now there's only one fraction instead of two. Who cares? Look at all this repetition. How many times are we writing A1s and such? Multiplication is great. We invented it to avoid repetition, right? I don't want to do that 2,000 times. That is so much easier, you know? And what's happening up here? We have multiplication. These guys, multiplication. There's instructions to tell you how to get the answer in other ways. So don't do all this other stuff. And with algebra, you don't have to. In arithmetic, for some reason, they don't like this, and they want you to do all this work for no reason, because you could have just done that. So algebra is awesome, so easy. So yeah, just a couple of steps and boom, we've solved every problem. So you don't have to do any of that. All we did was change the name to another name of the same thing. So the answer, let's use our nice version of the first thing we had for x. Here's the name of the number. Copy. That's the x coordinate. And let's get rid of all these other. Remember, y'all, every pen stroke counts. Come here, get that. Okay. Let's kind of make it all nice and pretty here. That's the the x, and then where was our y? It was this guy right here. Boop. Doodle-doodle-doodle-doo. See, it took longer just to rewrite the name of the x than it did to just do the whole problem. Oh, and I don't want the y equals in there. That looks silly. I want this guy right there, and I want to resize it. That's the coordinate. That's where they cross. So give me any two lines, any two at all. It doesn't matter. And any two lines look like this. A1, B1, C1, A2, B2, C2. This is what any two lines look like. Give me any 6 numbers. Boom, I got 2 lines. Here's the answers to every single possible one of them. We just solved an infinite number of problems. That's so much easier than let's throw fractions in, right? Why solve them one at a time? Why put a 1/2 here and a 2/3 there and a √3 here? Why do all of that? Again, what did we do? We multiplied by a2, we multiplied by a negative a2, and that gave us a1, a2, x, b1, a2, y, a2, c1, and then down here, negative a1, a2, x, minus a2, b2, y, negative a2. Wait, c2, there we go. Did I get it right? Everything get an a2? Yep. Everything get a negative a... Oh, this should be an a1. There, negative a1, negative a1, and then a negative a1. I'm trying to do it as fast as I can, but I'm going to do it without making mistakes because I'm going to double check. A2, A2, A2. Yep. A1, B1, C1. Negative A1, negative A1, negative A1. A2, B2, C2. Great. And then we added. Boop. Cool. Those canceled out. I had B1, A2 and A1, B2. That's how many y's we had. And over here, we ended up with this. Boop. Great. So then our y was this. Doodle-doop. Divided by, boop, this. Do-do-do-do-do. Great. That was our y. And to get our x, I'll put a box around that guy. So substituting in to either equation, let's pick that one. Substitute in what y is, so we'll move this over, get rid of this guy. Here's our y. Copy, paste. Let's get rid of that. And now let's grab you again. There. That's our substitution. Substitute. Awesome. So to get our x, we had C1, and then we subtracted this from both sides. Cool. And then we had to divide everything by this. So 1 over A1. Cool. And that's our x. Oops. So the answer to every single question of where two lines cross is, here's our x coordinate. Oh, let's get rid of you and make you a little smaller. That was our x. And where's our y? Oh, there it is. Boom. Now, I don't know about you, but doing this one problem is actually a whole lot easier than most of those arithmetic problems where you're clearing fractions and all that stuff. This is the answer to all. This is algebra. That's algebra. And for some reason, we don't teach algebra in algebra class. We teach arithmetic, pre-algebra. It's like they think that you couldn't figure out how to do this. This is so much easier. Y'all are just so trained to do things the hard way. You have to turn this into that. That's a lot of work. How many is this worth? How many is this worth? Well, that many, and if you add them, you're just putting them in one big pile, and you have to figure out the name for how many that's worth. Here, we're doing exactly the same thing, but we don't have to know any of this stuff. You don't have to know any of that. You just say, that's how many. That's the name. Algebra is so much easier, and it's unfortunately that they don't let you learn it. It's blinding. So, yeah. Here soon I'll have another video because this is great and all, but it's there's a whole lot of redundancy. You're going to get to where, like, why are we writing the x's and the y's over and over again? The more stuff we write down that we don't have to, the more likely we're going to make a mistake. You saw I was making mistakes, and I had to go back and double check. Well, the better your notation, the less you're writing stuff you didn't need to write, the easier it is to think and flow, the less probable it is you're going to make a mistake. So the next up is better notation. Okay, better notation. I thought I turned that off. Better notation. Notation. Okay, just like this was terrible, we did this, right? And just like adding 2002s was terrible, because you could make a mistake. And even if you didn't, the reader could make a mistake. So we invented notation. Okay, instead of having this, oops, and this, really all that mattered in the end was what we call the coefficients, the numbers out front. So we could have just done this, just write down a 2 and the 7 and the 3 and the -5 and a 1 and a 2. Now we do exactly the same math, exactly the same. But we don't write a whole bunch of stuff that we never had to write. There's your x column, here's your y column. And this is called an augmented matrix. So I'll show you that next time. And this is really an adaptation of this. That's called a matrix. This is called a vector. This is linear algebra. Boom. So we've gone from arithmetic to algebra to linear algebra. And this is tedious because, again, we don't even need to write that. So this is just a faster way of writing that. And it's cool. I hate that we skipped this in class because this is a new object. It is a matrix. This is a new object called a vector. And it's nice to be able to do math with things that are more sophisticated than just, hi, I'm a fancy way of representing this many, right? It's the simplest data structure there is. Now we got these other objects that we can multiply and compare. And just to catch a glimpse of these other objects would be cool, but they think you can't understand anything like that, that there might be something more sophisticated than a number. So they hide all that and they jump straight to this because this is faster for calculating. Computers can calculate. We don't need to do that. What I want to teach y'all is what math really is and how to develop a mind that can advance math, because that's going to be useful, because that's what we use to make the AI better, to make the computer better. There's no point in training y'all to compete with a computer. So yeah, that's what's up next, and that'll be the last part of solving systems of linear equations. Love y'all. Thank you so much. Your virtual presence is what extracts the ideas from me. It basically pulls the information from the universe behind me, through me, and then out to y'all. I'm not responsible for any of this, I swear. See y'all next time. Thank you.